This is a special episode for those of us who have quads, magnepans, or other electrostatic speakers, because unfortunately I have been really negligent so far and I haven't posted many videos or any videos on that subject. So for those of you who have quads and Maggies and you've been sticking around for advice, finally I'm listening to you, and here's something truly special. And it's a Bob Carver Crimson 275 stereo amplifier, and it has KT120 power tubes, 1 pair per channel in push-pull configuration, and we have, it has 3 vacuum tubes, the small ones, which are doing the phase splitting and the driving of the amplifier. So the input tube and the phase splitter. So now, what about this amplifier? So it seems like a really nicely built, a really perfect, beautiful design, really robust transformers, and the pricing, it says under $3,000. So it's at a very good value for what we get. So I know this is a lot of money for most of us, but unfortunately quality comes at a price, and this is a price point and performance point which should be considered by serious audiophiles. So this is where you can already get an amplifier that performs to excellence. You will have fantastic sound, but it's not yet at a price which is something silly, and we are not entering the boutique category yet, because the boutique category is where you have like really extreme designs, extreme things. You might be getting a tiny bit better sound by them, maybe a lot better, but with extreme price cost, and this is something special. There is Bob Carver. Actually, he's one of my heroes. He's always been. He is a genius of amplifier design, and I just recently realized that he has a big selection of vacuum tube amplifiers, and I'm really glad about it, because I knew of his genius for a long while, but unfortunately he was kind of inaccessible to me, because I do not know much about solid-state circuitry. However, let's have a look at his tubes. So this amplifier is really special because it can drive very demanding, very current demanding loads. So this is perfect for quads and Maggies. So let's see at the description. So it's 175 watts per channel into 8 ohms, and it can drive loads under 2 ohms as well. And it says that there's one 1287 in it and 2 12AX7 tubes, and the 1287 is called part of the DC restorer circuit. So this nomenclature is unfamiliar to me, but let's see. Let's have a look at the schematics, and let's see what does that mean. And here we have other information, and frequency response 0 dB to -3 dB, 16 Hz to 35K. So it has a nice wide frequency range, well-designed output transformers, low distortion less than 1%. And you see it's not like 0.00 blah 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 percent. It has like a human distortion, and under human it means like performance that is that will produce musical sound. Because if you have high distortion, like several percent range, or you have like very close to 0% distortion, both of those are not good. Because if the distortion is virtually 0, it means that the amplifier is using way too much error correction, so it will sound extremely mechanical and unnatural. and if it has high distortion, it will sound very syrupy, sweet, uncontrolled. And here it's neither the case, he has it at the golden ratio. So now let's have a look at the schematic. And this is absolutely fantastic that he publishes the schematic online. There are extremely few manufacturers who do that, and when it happens, it's always a sign that the person really knows what he's doing, that he makes the schematic public, and it's really fantastic. So essentially, let's have a look what's going on here. So if you've never seen a schematic before, then let's just see. So this is the representation for the power transformer. So this side shows the primary, so it means that this is the side that's plugged to your AC outlet, and there's your power switch, and here we have the fuse. So let's see what's going on. So you see the power switch here, it connects the two sides of the primary together or lets them disconnected. So when it's connected, then electricity can flow through, and then on the secondary you have output. If it's disconnected, they do not make a connection, and the amp is off. So what's going on the secondary side? We have one secondary winding, this is the filament winding, so it means that the electricity coming off here will heat the vacuum tubes. And here we have another secondary, and what is this doing? This creates the bias voltage. So and the bias is, he shows even the voltages here, it's minus 41 volts. So that means that the power tubes use a so-called fixed bias. It means that their operating point is set by a minus 41 volts voltage. And the other option to try is to use self-biasing, and in that time you use the cathode resistor to allow the vacuum tube to find its operating sweet spot. So here we also have our last winding, and this is the secondary for the B+. And you see the B+ in vacuum tube designs means high voltage, and under high I mean several hundreds of volts. So we have here 4 high voltage points that are using the B+1, it means that's the first high voltage. We have a B+2, that's the second, a third, and the fourth. So we have 4 high voltage sources. The first high voltage source, you look at that, 685 volts. So that's on the plate of the KT88. So that's the voltage that is accelerating the electrons inside the amplifier. The second voltage, the 340 volts, that's the voltage for the screens. So it means, anyway, I won't get into that because this video will never end. Anyway, that's the screen supply, which is about half of the plate voltage. And these two voltages here, we have a 435 volt and 340 volt. So these will be for the phase splitter and the driver section. And now let's see how did he do the filtering for these supplies. So let's see, for the filaments, negative, positive. So look at that. So the filaments are AC heated. So you see that there is no rectification and no filtering after that. They are connected to the tube filament. So all of the tubes are connected in series. So basically we are using AC heating, and I will expand on that in another video. And let's see, for the bias voltage, he uses half wave rectification. So there's only a single diode. And then we have a small capacitor, only 22 microfarad, that's unusually small. And then a 6K resistor, another 22 microfarad capacitor. And then we have voltage, 2 resistors, which is a fixed resistor and a pot. So with the pot adjusting the resistance here, you can adjust the bias voltage. So this is how you can set the operating voltage for the tubes. And I would say what my comments on this as a tube amp builder is that half-wave rectification is really undervalued in the tube amp community, and I have found that when you apply that, it gives a more natural, more human, more lifelike sound than full wave rectification or a Grates bridge, which is using 4 diodes. However, the drawback of that, why it's not used as frequently, is that it has very high hum. So you need a lot of filtering to get rid of the hum. And I'm really wondering, because he uses extremely low capacitances here. So the bias voltage has a really high hum component on it. And I think what he does, because when you look at the B plus supply, it's also half wave, but it's half wave voltage doubler. So you see 2 diodes, and one diode is right here, and the other diode goes to ground. And then you see that here there's a snubber circuit around the diode to quiet down, get rid of the diode noise. This is fantastic. He really knows what he's doing. And we have 300 microfarad capacitance. 2 of those capacitors in series, so basically that gives us 150 microfarads for the first filtering capacitor in the high voltage. And at the half point, it feeds to the screen voltage. And the screen has a 47 microfarad cap afterwards. So there's a pretty high hum component on the screen, and also here pretty high hum component on the plate. And there we have resistors dropping the voltage further for the phase splitters, and there's 220 microfarads for that, so that quiets it down quite a bit. And then resistance, another 47 microfarads, and that's the input tube's voltage. So by here it's relatively hum free, but the power tubes are getting a very noisy power supply. And what Bob is doing is that he is balancing the hum here that is at the plate screen with the bias. So we have hum components that comes from the 60 Hertz AC line, and he uses one to cancel out the other. And this is a great way to achieve a quiet power supply without getting more complicated power supply filtering, which is much more expensive. So it has benefits and drawbacks. The benefit is that it makes the amp much cheaper, so you can have a quiet amp at a good price point. But the bad thing is that still, because you have the hum coming in and you are cancelling hum with hum, you are really losing the micro detail level. So the supply is not quiet enough to handle micro details. And also we can get away with it because it's a push-pull design, and then push-pull design have a really good hum and noise rejection from the power supply side. So I would say that if you have this amp and if you want to modify it and you want to make it improvement on it, then I would say like beef up the power supply, but it's kind of hard to do because there is not enough space in the chassis to do that anymore. And that was not how this amp was designed. So I would say at this point that if you want to DIY it or mod it, let's just hold off on our horses with that. Maybe I could do another episode for that. I'm not really prepared at the moment to give advice for that. However, here's one more thing that I haven't mentioned. On the cathode of the output tubes, there's it looks like it's a constant current source that locks the KT120s into a constant current mode. And that really helps with getting a more stable behavior at low frequencies. Honestly, this is I think it's really good that Bob is doing it, because he knows transistors inside and out. I myself, I do not use constant current supplies. I know very little of solid state devices, and honestly, I think they make the sound more powerful but more artificial. So it works really well if you are into jazz and you listen to jazz quartets and you just go for speed and punch. But if you want to listen to violins, music with harmonic content, wooden body, tone, then these solutions always mechanize the sound, so I do not prefer that so much. However, in this case, I do not begrudge this solution, because I'm recommending this amplifier now for electrostatic panels, and there I would say this is a huge help to provide that current demand that they need. So now let's go into the actual schematics of how the tubes are tied together, was the topology of the amp, because this was the power supply schematics. And this is the amp schematics. But now let's make another video of that, because now we are hitting 15+ minutes. So thank you for staying here with me, and please like and subscribe so others can like and subscribe. Bye bye.